How do we find holes in rational functions? So suppose a rational function, f(x), such as this one over here, passes through a coordinate but is undefined at that value. Then that coordinate is called a hole. A hole exists only when the denominator and the numerator of a rational function have a common factor. And so you might say that my function, which is f(x) plus x squared over x, does not look as if it's got a common factor. That's okay. We can rearrange this equation. So if I was to factorize the numerator and took out the x out, and then I would have 5 plus x over x. Now my common factor is x. Or I should say x minus 0, which means that when x is equal to 0, my y value or my function is undefined. And therefore, there is a hole at x is equal to 0. Let's have a look at another example of a function. Okay, these rational functions will need to be factorized. Now that we have factorized it, we can see that there are two common factors, x plus 2 and x plus 2. They are common to both the numerator and the denominator. And fx is now x take 4 over x plus 3. And so we have a hole at x is equal to minus 2. And I can illustrate this to you by showing you this graph where you can definitely see that at minus 2 we've got an undefined. Okay, please note this very carefully. This is the graph of the function x squared minus 2x minus 8 over x squared plus 5x plus 6. Now I'm going to show you the same graph, but this time notice that on the graph minus 2 is recorded at minus 6, and this is the graph of x minus 4 x plus 3. And as you can see, these are identical graphs, but one of the functions has a hole in it and the other one does not. Just going back to that first example where we had 5x plus x squared over x. We factorized it by putting the x out and left it at 5 plus x over x. That means that these two now cancel out because these have the hole in it, and we are left with only 5 plus x. These two graphs are identical, but this one here has a hole at x is equal to 0, whereas this one over here, there is no hole. And I'll just do one more example before we wind down. But before I do so, please subscribe to this channel for me, and also put thumbs up, because that's really important for my channel to get popular. And at the same time, if you have any problems that you'd like me to work out, I will endeavor to do them immediately and give you a shout. I'm also doing probably a whole playlist on rational numbers, so there's a lot more coming there about rational numbers. Now let's just try example 3 now. right, let's say that my function is now minus 2x plus 8 over x squared minus 6x plus 8. So what do we do first? First of all, we try to factorize this, and I can see that I can take the minus 2 outside. If I take out the factor minus 2, then I must have minus 4 here, because minus 2 times minus 4 gives me plus 8. And this one is be x, and 2 and 4 here, and therefore I will need minus 2 minus 4 to give me minus 6, and minus 2 times minus 4 gives me 8. So that tells me that I have these two are common factors. So I'm left with minus 2 over x minus 2. All right, now what did we say? There is a hole here, okay, for this one, a hole at x is equal to 4. And with this one over here, this function, there is no hole. And those two functions, when they are graphed, will look exactly the same except for that particular point. Actually, I just should say that particular coordinate.